What if humanity's next great leap lies above a planet that should kill us instantly? Venus, blazing in our sky, second from the sun, once Earth's sister, now burns alone. Its atmosphere is poison, its surface, a furnace, its winds howl at hurricane speeds, and yet some believe our future could float in its clouds. To understand what makes Venus both terrifying and tantalizing, we must first descend through its atmosphere, layer by layer, into a world where physics turns savage. The upper layers are silent. Sunlight pierces the clouds, diffuse and golden, but beneath that peaceful veil lies chaos. The temperature rises swiftly. The pressure climbs brutally. By the time you reach the ground, you are facing 92 times Earth's atmospheric pressure, equivalent to being submerged beneath a kilometer of ocean. The temperature, 480 degrees Celsius, enough to melt lead, enough to dissolve human ambition in seconds. The very air is carbon dioxide, thick, suffocating, and seething with heat, trapped by one of the most intense greenhouse effects in the solar system. High above, clouds swirl not with water, but with sulfuric acid, corrosive droplets that burn through metal, glass, and bone alike. The winds near the cloud tops whip at over 360 kilometers per hour, so fast they circle the entire planet in just 4 Earth days, a super rotating maelstrom of blistering speed and boiling skies. Venus is not just inhospitable, it is predatory. And yet, within this furnace, humanity sees a strange opportunity. Before it became a furnace, Venus may have been a sanctuary. Imagine a younger solar system, planets still cooling, oceans forming from primordial steam. On Earth, life was beginning to emerge, simple, single-celled, clinging to warmth and water. And on Venus, perhaps the same story was unfolding. Many scientists believe that billions of years ago, Venus was not the scorched wasteland we see today. It may have had shallow oceans, flowing water, a temperate climate, a world not unlike the early Earth. For eons, Venus may have hosted a stable atmosphere, with water vapor and perhaps even rainfall. Its volcanic landscape may have cycled nutrients between land, air, and sky. NASA climate models suggest that if Venus had an ocean just 10 meters deep, it could have maintained Earth-like conditions for up to 2 billion years. 2 billion years. Time enough for life to begin. Time enough for it to evolve. But something went wrong. The sun grew hotter. Volcanic activity may have released vast amounts of carbon dioxide. Without a protective magnetic field, the solar wind began stripping away hydrogen, the lightest, most vital element in water. As water vanished, carbon dioxide surged. Water vapor, a potent greenhouse gas, thickened the air. Heat trapped heat. The cycle fed itself. What began as warming became planetary fever. The clouds turned yellow. The oceans boiled away. Venus was remade, not by flame, but by its own breath. It became the monster we know today, and Earth's twin became its opposite. Venus now stands as the ultimate cautionary tale, a world that had everything and lost it, not from war, not from collision, but from imbalance. Studying Venus today shows us how small changes, tiny shifts in chemistry, can trigger tipping points, and tipping points are hard to stop. Venus didn't die in an instant. It drifted, gradually, silently, until no turning back remained. And if it happened once, it could happen again, on Earth. To understand Venus is to look into a cosmic warning sign, but also a ghost of what once was. And perhaps, the silence we see today is not lifelessness, but memory. Could humans really live on Venus? Not just visit, but stay? Our fascination with Venus is ancient. The Babylonians tracked its wandering motion. The Mayans carved it into their calendars. In nearly every ancient culture, Venus was a goddess, a harbinger, a warning. In the modern era, it became a target. The Soviet Union led the charge. The Venera program, spanning from 1961 to 1984, launched over a dozen probes toward Venus. Most were destroyed, but some, like Venera 7, succeeded. Venera 7 was the first human-made object to land on another planet and transmit data. It lasted 23 minutes before succumbing to the crushing pressure. Later missions, such as Venera 9 and 13, sent back haunting images, jagged stones, cracked terrain, and a dusky, filtered horizon. Venus was no longer an idea. It had a face. Then came NASA's Magellan in 1989, using radar to peer through the clouds. It mapped 98% of the surface, revealing volcanoes the size of continents, lava plains, and signs of tectonic chaos. And now, Venus is rising once again in the eyes of space agencies. Da Vinci Plus will analyze its atmosphere during descent, seeking clues about its ancient oceans. Veritas will remap the surface with unparalleled resolution. ESA's Envision will study the planet's crust, core, and atmospheric layers. Private companies, too, are looking upward. Some envision robotic mining, others propose cloud habitats. The race to reclaim Venus has quietly begun. If we cannot survive the inferno below, then perhaps we can build above it. About 50 to 55 kilometers above the surface of Venus lies a narrow ribbon of hope, an atmospheric layer where the impossible becomes imaginable. Here, the temperature is a mild 21 degrees Celsius. The pressure, similar to what we experience at sea level on Earth. No crushing weight, no searing heat. It is the only place on Venus where human technology and biology might thrive. And here, a dream emerges. Floating cities, suspended like lanterns in the clouds, not built upon the ground, but held aloft by physics and engineering. These habitats would take the form of aerostats, massive helium or hydrogen-filled structures. Think of them as airborne superstructures, similar to futuristic zeppelins, designed not just to float, but to live. The atmosphere of Venus is so dense that even breathable air, a mixture of nitrogen and oxygen, is itself a lifting gas. Our life support atmosphere could double as our means of staying aloft. Imagine a colony, a gleaming, high-tech superstructure the size of a city block, wrapped in acid-resistant skin, gently bobbing in Venus's golden haze. Solar panels stretched like wings harvest energy from a sun that shines brighter than it does on Earth. Power flows into life support systems, communication relays, hydroponic gardens. Inside, corridors curve like arteries. Greenhouses glow under artificial light. Walls hum with filtration systems, recycling every molecule of air and water. Nothing is wasted. Everything circulates in an endless loop. An ecosystem in miniature, suspended above a planet that cannot forgive a single mistake. Daily life here would be strange, beautiful, and disciplined. Windows would reveal a world without ground. Only cloud below, cloud above, and an endless amber horizon. The sun would rise and set through thick copper-colored skies. Every movement would be measured, every breath filtered, every drop of water reclaimed. Scientists would monitor the atmosphere, searching for signs of life or chemical oddities. Engineers would maintain the hulls, checking for corrosion or leaks. Artists, philosophers, and dreamers might write poems about the silence, about what it means to live above a world you must never touch. And yet, beneath this beauty, danger brews. The atmosphere may be calm at this level, but storms brew below. A system failure could send a module descending, drawn downward into a hell of pressure and heat. For this reason, redundancy would be critical. Multiple lift systems, emergency balloons, auto-leveling gyroscopes, fail-safe systems that deploy instantly at the first sign of drift. And then, there's the acid. Venus's clouds contain tiny droplets of sulfuric acid that would corrode exposed metals and plastics. Every surface must be shielded, coated in Teflon-like polymers, or built from new materials engineered to resist decay in the most hostile of environments. Even communication is a challenge. Venus's thick clouds block many radio frequencies. Relay satellites would be required in orbit, bouncing messages between Earth and the cloud cities. Yet the advantages are equally compelling. Solar energy is abundant, nearly double the intensity received on Earth. The thick atmosphere provides natural shielding from cosmic rays, and the constant atmospheric movement, superrotation, could allow cloud cities to move with the wind, or even position themselves strategically for observation, research, or resource harvesting. Over time, multiple habitats could form a sky-based civilization, linked by airships, drones, and tethered walkways, a floating archipelago of science, survival, and perhaps, one day, culture. And unlike the Moon or Mars, gravity would feel familiar. Venus has 90% of Earth's gravity, a crucial factor for human health over long periods. Bones would not weaken, muscles would not atrophy. Children born in the clouds of Venus might grow up never knowing the difference. But would they feel safe? Would they feel at home? That is the philosophical question behind these sky cities. To live on Venus is not merely to adapt, it is to defy, to build comfort above chaos, to craft a future above a grave. It is not a retreat, it is a reclamation, a statement that even in the most hostile corners of our solar system, life can rise, if only it dares to float. Surviving on Venus will require technologies we've barely imagined. Corrosion-resistant materials, such as Teflon-coated polymers and acid-stable alloys, will shield outer surfaces from the sulfuric mist. Radiation-hardened systems will protect electronics, though the thick atmosphere itself provides better shielding than Mars. AI-assisted maintenance bots will monitor, repair, and upgrade equipment autonomously. Modular architecture will allow damaged habitat sections to detach and be replaced mid-air. Emergency buoyancy systems will keep critical systems afloat if one section fails. Atmospheric mining could become a source of fuel or raw material for further space exploration. Venus's carbon-rich atmosphere may one day power missions to Mars, the asteroid belt, or beyond. These cloud cities could become floating refineries, stepping stones across the solar system. But not every threat is physical. In an environment where you cannot open a window, where the skies are always orange and the Earth never rises, mental strain becomes a silent adversary. Isolation. confinement, sensory monotony all have psychological effects, especially over long durations. Astronaut studies on the ISS, submarine crew reports, and analog simulations on Earth all warn the same. Without care, the mind erodes. To prevent this, future Venus habitats may need more than technology. They may require virtual reality gardens to simulate nature, social rituals to anchor human identity, creative spaces for expression and healing, psychological support AIs, capable of monitoring and uplifting mental health. In the clouds of Venus, our minds may become the most fragile frontier. In September 2020, something extraordinary happened. A team of astronomers announced they had detected phosphine in Venus's upper atmosphere, a molecule rarely produced through non-biological means on Earth. On our planet, phosphine is created by certain anaerobic microbes, life forms that thrive without oxygen, deep in swamps, sewage, and the guts of living things. The signal was faint, the margin of error debated, but the possibility electrifying. Could Venus, the planet we wrote off as dead, still host life in its skies? Imagine it, microscopic organisms floating in droplets of sulfuric acid, evolving in the high clouds for billions of years. Creatures so alien they require no solid ground, only suspended particles, diffused sunlight, and the chemistry of survival. No rivers, no soil, no forests, just life clinging to the sky. This isn't just science fiction. In fact, Carl Sagan suggested it as early as 1967. He theorized that Venus's upper atmosphere might contain microbial ecosystems, drifting in stable, relatively habitable layers, entire biospheres that never touch the ground. If such life exists, it would be the first extraterrestrial biology ever discovered, a second genesis, proof that life is not a miracle confined to Earth, but a process, waiting for the right chemistry. But this discovery, if confirmed, would bring heavy consequences. Suddenly, Venus is no longer an empty world. It is a living system. However primitive, however fragile, would we still have the right to colonize it? Terraforming would become biological genocide. Even atmospheric mining could unbalance a delicate ecosystem we barely understand. And yet, the argument grows more complex. What if the life is truly microbial, incapable of thought or emotion? What if it poses a threat, mutating on contact with Earth organisms, or worse, infecting astronauts? These questions force us to confront a deeper truth. We are not ready for life beyond Earth, not scientifically, not ethically. The discovery of alien microbes in Venus's clouds would rewrite biology textbooks, reshape religious philosophy, and ignite debates in every nation. What rights would such life hold? How would we protect it? How would we study it without destroying it? The answers may define the next century of space exploration. For now, the phosphine signal remains unconfirmed. Later observations challenged its presence. Some scientists suggested sulfur dioxide as a possible false positive. Others proposed unknown photochemical reactions, but the spark has been lit. We now know the clouds of Venus are not empty. They are dynamic, reactive, surprising, full of chemical whispers and ghostly mysteries. And even if life does not exist today, it might have once. Venus could have supported life billions of years ago, before its oceans boiled away. Fossilized biosignatures may still linger in its upper atmosphere, waiting to be detected. Isotopic ratios, chemical imbalances, the fingerprints of a lost world. And perhaps that's the most haunting thought of all. Not that life is out there, but that it was. That Venus was alive, and we came too late. Venus is a wound in the solar system, a place that could have been a sister, but became a warning. And yet, in that wound, we see a seed of learning, of caution, of audacity. If we can survive here, if we can build above fire, we prove that human resilience is not bound by soil or sea. Floats, it dreams. Above the furnace, we find hope. Not because it is safe, but because it is worth the risk. If you found this journey through the dark intriguing, like this video and subscribe for more content about the mysteries of our universe. Together, let's keep asking the big questions and reaching for the stars.